Today we're going to talk about distance and time problems. These are the infamous train problems that everybody remembers from Algebra 1. There's two kinds of problems that we could face. In the first kind of problems, we're going to have two equal distances, and we're going to be setting the different rates and times equal to each other. In the second kind of problem, we're going to talk about two trains going a combined distance. We're going to set those up in two different videos. In this video, we're going to talk about problems where we have an equal distance. If we read our problem here, it says a train leaves the station at 1 p.m. at a rate of 60 miles per hour. The second train leaves an hour later and travels at 96 miles per hour on the same route, so they're going on parallel tracks. In how many hours will the second train catch up with the first? We don't need to know that the first train left the station at 1 o'clock. While that's interesting information, in the course of this problem, it's superfluous. Sometimes we do need to know the leaving time, but right now, all we really need to know is the second train leaves an hour later. We also need to know that the rate of the first train is 60 miles per hour. The second train is 96 miles per hour. It leaves an hour later. And we need to know that they go on the same route, okay? I want to know how many hours it will take the second train to catch up with the first. If these two trains are traveling on the same route, that means that they're going to wind up going the same distance if this is train A and this is train B. Train A leaves the station first and travels a certain distance. Train B leaves an hour later, but he still travels the same distance. So we are going to set these two answers equal to each other. I know that my formula for distance equals rate times time. In this case, both trains are traveling the same distance, so we are going to set the rate and time of each train equal to each other. I'm going to call the first train train A, and the second train train B. I already know the rate of train A. I know that the rate is 60. I know that the rate of train B is 96. What I don't know is the time. I do need to set a time. I either need to make my time equal to train A or train B. I'm going to just go make it simple. I'm going to let T equal the time for train A. So on the left side of the equation, it's just 60 times the time. On the right side of the equation, I need to figure out what my time for train B is going to be. I know that train B leaves an hour later. So if train A travels for 4 hours, that means that train B is only going to travel for 3 hours because it leaves an hour later. So if I take my time for train A and subtract 1, I'm going to get my time for train B. So inside the parentheses, I'm going to put T minus 1 because T is train A's time. Now all I have to do is solve this equation for T. I'm going to start by distributing my 96. So it becomes 96T minus 96. Over on the left side, I've still got 60 times T. Subtract 96T from both sides to get the variables on the same side. 60 minus 96 is negative 36T equals negative 96. Now at this point I should be a little alarmed that I've got negatives in the problem because you can't have negative time or negative distance. But if I look, both sides of the equation are negative. So when I divide by negative 36, my negatives are going to go away. I divide both sides of the equation by negative 36, and then if I go to my calculator, negative 96 divided by negative 36 is 2.6 repeating. Now we know 2.6 repeating is really 2/3, so this is 2 2/3 hours. So in 2 2/3 hours, train A or train B will catch up with train A. If I wanted to write that in minutes, I know 2 hours will stay 2 hours. 2/3 times 60, because there's 60 minutes in an hour. I can just go through and do this math on my own. I can divide 3 and 60. They have a common factor of 3. So this is 2 hours and 40 minutes.